Today we are going to start with the new topic, which is called the completing squares. This is a very important topic, and I'm going to show you how to do the completing square with an example. But before we talk about completing square, I'm going to refresh your memory. Remember that when we have x plus a squared or x minus a squared, we did the expansion of these two and we got these two formulas. And these are the two identities that you always have to remember. It's very important. Now let's do one example to see how the completing square works. It's a little bit confusing at the beginning, but after a while when we do the examples, you will see that it's very simple. The question is that if I have y equal x squared plus 8x plus 5, how do you change this into a vertex form? And from there I have to find the coordinate of the vertex and then plot the graph. To change any quadratic relation into vertex form, what we are going to do is that first we have to make sure that the coefficient, the leading coefficient, i.e. a, is equal to 1. In this case, y is equal to x squared plus 8x plus 5. Automatically, the coefficient of x squared is 1, so I don't worry about factoring out the coefficient. The next thing I always do is that I'm going to package the two terms which are involved with, which have the variable included. So I'm going to write this one as x squared plus 8x and then plus 5. Now, what I'm going to do is that inside the bracket, I'm going to add half of this coefficient squared and then subtract, meaning I'm going to write this one as x squared plus 8x plus 8 divided by 2 is 4, so 4 squared. I add and I subtract 4 squared, so nothing is changed here. Now I'm going to take these three terms together, so x squared plus 8x plus 4 squared is 16, and then I take this one out and combine it with 5, so I get minus 16 plus 5. Now, if you look at these, x squared plus 8x plus 16, and if you remember a plus b squared is equal a squared plus b squared plus 2ab, this one can be written as x plus 4 squared, because it gives you x squared plus 2 times 4 is 8x plus 4 squared, which is 16, minus 16 plus 5 is negative 11. You can see that using completing squares, I changed this quadratic relation into a vertex form. Now it says part B, find the coordinate of the vertex. If I look at part B, if I look at this equation, I can see that the vertex is going to be negative 4 and negative 11. Remember, the equation is x minus h squared, and this is plus 4, so this means that h has to be negative 4, and k is negative 11. Now I'm going to use this information to plot the graph. I'm going to find another point on the graph, which is the y-intercept, and the y-intercept is the constant here, is equal to 5. So I know that the y-intercept is here, this point. Also I know the vertex is negative 4 and negative 11, so negative 4 and negative 11 is going to be somewhere around here. Now, I know the y-intercept is here. Also, I know that the axis of symmetry is x is equal to -4, and since the quadratic, the parabola, is symmetric about the axis of symmetry, the other point is going to be 5 units to the left of axis of symmetry, 4 units to the left. So 1, 2, 3, 4, so it's going to be right here. So I have 3 points, and I can draw a smooth curve going through these 3 points. Now we are going to do second example. We have been given the quadratic relation 2x squared plus 12x plus 11, and we are supposed to find the maximum or minimum point. Without even trying to find the maximum or minimum, you can see that a is positive, so parabola opens up, so it has to be a minimum. Now, how do we use completing square to find the maximum minimum? Again, if you remember, I said it before, that you have to make sure, first of all, we take the first 2 terms that they are involved with the variable x. So I can write this one as y equal 2x squared plus 12x plus 11. Now I'm going to make sure that the leading coefficient of x squared is going to be 1. So this means this 2 is the problem, so I factor out 2, so I get 2 open bracket x squared plus 6x plus 11 is equal to 2. Now I'm going to add and subtract. 6 divided by 2 is 3 squared, and subtract 3 squared. So I get x squared plus 6x. 3 squared is 9, subtract 9 plus 11. Now I take these 3 terms together, so I get 2 x squared plus 6x plus 9, and then I distribute 2 inside the bracket, I get -18, so I get -18 plus 11. Now x squared plus 6x plus 9 is just x plus 3 squared, and -18 plus 7 plus 11 is going to be -7. So from here I get that the vertex has the coordinate -3 and -7. So this means that since a is positive, parabola opens up, so this point is minimum, and the minimum value is -7. The next example is a ball which is thrown upward, and the path of the ball follows this equation. First of all, you can see that a is -1, so the parabola opens downward, which makes sense. X is the horizontal distance in meters from a fence, and y is the height in meters above the ground. First, the question is that what is the maximum height of the ball, and at what horizontal distance does it occur? And the next part is to sketch the graph. Again, to find the maximum height, we are going to use completing square to change this one to a vertex form. So, as usual, I'm going to take the first 2 terms that they have the variable, and I'm going to write minus x squared plus 2x plus 3. Now, since the leading coefficient is not 1, I'm going to factor out -1. So I'm going to say negative x squared minus 2x plus 3. Now I'm going to divide 2 by 2, which is 1, square, add the square of it, and then subtract. So I'm going to write negative x squared minus 2x plus 1, because 1 squared is 1, minus 1 plus 3, which is negative x squared minus 2x plus 1, I put them together, and then I take negative 1 out of the bracket, but there is a negative here, so it's going to be plus 1 plus 3. Now x squared minus 2x plus 1 is really x minus 1 squared, and 3 plus 1 is 4. So what we got here is the vertex form, which tells us the vertex is at 1 and 4. Now since the leading coefficient is negative, the parabola opens downward, so this point is maximum. The maximum happens at x equal to 1 and y equal to 4. Now the next part of the question is plot a graph representing the path of the ball. We know that the vertex is 1, 4. So the vertex is going to be somewhere around here. This is the point. We're also going to try to find the y-intercept. You can see the y-intercept is just a constant, which is 3. So y equal to 3 is the y-intercept. We know that the axis of symmetry goes at x equal to 1, and since the parabola is symmetric, if y-intercept is at 3, the other point has to be a mirror of this point about x equal to 1, which is going to be this point. So now if I connect these 3 points together, I get the graph representing the path of the ball. Our last example is an application of using the completing squares to find the maximum minimum. The question is the following. You have Alex, which runs a snowboard rental business, charges $12 per snowboard and averages 36 rentals per day. She discovers that for each 50 cents decrease in price, her business rents out 2 additional snowboards. At what price can Alex maximize her revenue? We know that revenue, R, is number of snowboards which are rented times price per snowboard, which is very simple. Number times price. Now, let's assume that N is number of 50 cents decreasing rental. So now I can write that revenue is equal to, if there is no decrease, we know that she charges $12, but if she decreases the price n times, meaning n 50 cents, so 12 minus 0.5 n, now the question is that how many rentals she's going to have. We know that when there is no decrease in price, there are 36, but every time she decreases by 50 cents, 2 more people, they rent a snowboard. So 36 plus 2n. Again, n is the number of 50 cents decrease in rental. If n is 0, then you get 12 times 36, which is the original one. But if n is 1, meaning that she decreases the price 50 cents, then the price for rental is 12 minus 50 cents, and the number of rental is 36 plus 2 extra. Now, if you expand this one using the arrow method, we are going to get negative n squared plus 6n plus 432. Now, just by looking at this quadratic, you can see that the leading coefficient is negative, so the parabola opens down, and the vertex is a maximum point, and this is what we're looking for, maximizing her business. Now, what I'm going to do is that I'm going to use completing square to change this one to vertex form. So I'm going to take these two terms together. I get negative n squared plus 6n plus 432. Again, the leading coefficient has to be plus 1, so I take negative out. So I get n squared minus 6n plus 432. Now, 6 divided by 2 is going to be 3, so I add 3 squared and subtract 3 squared. So it's going to be negative n squared minus 6n plus 3 squared is 9 minus 9 plus 432. Now I take these three terms, and you can see that these three terms is going to give me negative n minus 3 squared. Now a negative multiplied by negative 9 gives you 9 plus 431. 432 is going to give us 441. So it tells us that the vertex is at the point 3 and 441. So this means that if Alex lower the price 350 cents, meaning 12 minus 3 times 50 cents, which is 1050, then the revenue is maximized $441.